Good morning, ladies and Robert. Good to have you here today. Today we're going to devote as much time as needed for your preview here. And we hope we can get to everything here. I already have a question from Karina on number 6, and then we can handle other questions as they come forth. How's that? So here we have number 6, and number 6 says the arc of a circle with a radius of 9 inches has a length of 25 inches. So what this is what's called an arc length formula, and you can tell because of two things. It has an arc and a radius. And so the formula for radius for arc length is S equals R theta. And what I did is I think, at least I recall somewhere in the faint recesses of my memory, that I told you can put that on your ACP formulas chart someplace, right? Did I? So I'm not hallucinating, am I? Not this time. So anyway, that's going to be our formula, really. And so we want to find the angle. So we're looking for theta. So what we do is we take S and replace that with 25. And that's going to be equal to our radius, which is 9 times theta. And so theta is going to be equal to 25 over 9. And that's going to be in radians. And so we want to find to the nearest degree. How do we go ahead and change this to a degree?
You have to multiply it by 180. No, yeah, 180 over 1 over pi.
180 over pi. So our answer should be 25 times 180 divided by 9 pi. Does that look right?
Yes, and I got the answer too.
Okay, 25 times 180. We're going to divide that by 9 pi. And just parenthesize that to be sure about it. So that looks good right there. So 159.15 so that'd be answer choice C. Okay? Questions on that? Any other questions on that? Yeah, just kind of go through as needed everything. If we need to go through everything, we go through everything. Now, a lot of this on the test, a lot of reference angle stuff. That's
Question on number 11, because it only has like,
number 11.
yeah, it only has tangent -1 and sine -1. What's this two other?
Okay.
That are within?
Let's talk about that. Okay, measure of angle theta Well, what we're given here is this. So what we have is we have our opposite side here, and we have our adjacent side here. And so opposite over adjacent is tangent. So we know that tangent of this angle here is equal to 29/36, right?
I understood that.
Okay, so if we want to find out what the measure of this angle is, we have to go ahead and take the inverse tangent of both sides. And do that, we get theta is equal to inverse tangent of 29/36. So this is going to be our answer. Answer choice A.
I also confused because two don't even have like sine or anything like that.
Yeah, now what this is this one is, that's equal to the tangent. That's equal to tangent theta. Okay? This is not equal to theta. So this is wrong because that's tangent theta. This one is wrong because this is cotangent theta. We want to have what this thing is right here, which is defined by this inverse tangent of 29/36. So it's just it's a way of, so that's what they are. Okay? You can see on your test one, very much like, I don't know, you might even be the same problem.
That's what we were doing wrong. Other problems yet? Yes.
On number 12, it says the measure of angle M is 33.5.
Degrees,
Do you multiply 0.5 by 60 or divide it by 60?
Yeah, okay. So here's your, you want to change this into minutes. So you're going to get 33 plus 0.5 degrees. And to change the minutes, you multiply by 60 over 1. So that's going to be 33 degrees. And that's going to be 0.5 times 60. So that's going to be 30 minutes. Answer choice C. Okay? So this is your
How? 1.5 times pi. Yeah.
Yes?
And how much will you multiply it, to a second, to a thousand, to
360.
130,
Yeah,
Like if you had like 260?
like if it was
to the 100?
33.52.
Oh, okay, okay. There, you'll do that example. That's gonna be 33 plus 0.52. We're gonna multiply by 60 again. So 52 times 60, or 0.52 times 60.
31.2.
So 31.2, okay,
By the 2 by 60.
yeah. 1.2.
You don't use future.
So we have that. So the next thing we're gonna do is take that 0.2, so that's gonna be equal to 31 degrees, 31 minutes, plus 0.2 times 60 to change the seconds. So that's gonna be 12. So we get 31 degrees, 31 minutes, and 12 seconds. That would be in DMS, if you had a decimal left over. Okay, so that'd be our answer to this hypothetical. I think on your test, I don't think I'm going to give you anything this day. I think I'm just going to move you to minutes. I don't think I'm going to move you into seconds. I don't recall. So what I did in this, most of this review preview I got from looking at the test and changing the test things a little bit appropriately.
Mr. G?
Yes.
Can you work on number 8?
Let's look at 8. We are here for 8. Okay, solve the unknown in the nearest tenth. And so basically what you're looking at is you have your angle here. So what sides are represented here?
Opposite over hypotenuse.
So you get an opposite over hypotenuse. And opposite over hypotenuse is what?
Sine?
So our sine of this angle
I'll show you, tell her the right thing.
is going to be equal to our opposite over our hypotenuse.
I was confused for a minute because Jada said you have to use tangent.
Yeah, now what happens is that she's not wrong to think about it. And I'll tell you why in a second. And the reason it just seems like that when you look at real world problems, more just end up being tangent somehow. Okay, it just seems like this length down here and this length are the ones that seem to pop up most often. But in this case, it's not it.
Yeah, okay.
Okay, this case is an application of sine.
Okay,
So then you make sure your calculator's in degrees, mine's in radians here. So let me see if I can find. So we have 42 sine 38 degrees. and 25.9 roughly. Best answer, B. Okay. All right. What do we got? Anything else? We need 9.
It's just, it is inverse of sine, so if you write about it.
Okay,
you just type it out.
Class, Karina's asking about 9.
You just put it as sine, and then you put it as.
What you have is 5 pi over 3 in standard position. Now, there are different ways of doing this problem.
It's just hypotenuse
Uh,
over opposite, so it's 55 over 11.
One of which
You just.
is to change to degrees,
It gives you that.
right? So if we want to change 5 pi over 3 into degrees, how can we do that?
For your direction.
Times
So secant is
Times pi over 180. Excuse me, time 5 pi over 3, 1 times 180 over pi, excuse me. There we go.
You don't have to make a calculator, unless you just want to put it into the calculator.
So what we have here is that will cancel out. 180 over 3 is 60, so we get 5 times 60. So we get 300 degrees.
I was still working on it.
And so here, what we have is we are right here
So your angle with the, well, the-
at 300 degrees, about right here.
If you're talking about angle of depression, you want the angle of the degrees on the.
Your reference angle
Do that.
is found by going straight up to the x-axis.
Here, and I have a line coming through and a line coming through.
It'll be this angle right here,
And so it's 22 and 46, but then the vertical
which will be 3, which will be, your answer's going to be 360 minus
it would be
300.
Wait, we're gonna be 300 minus 360.
No, and I'll tell you why. Your reference angle is always going to be positive.
If you look at this.
It's going to be positive, it's going to be between 0 and 90 degrees.
Where is?
And in radians,
We're here.
your answer is going to be pi over 3
And then
radians.
60 is the figure. Wait a minute. Oh, 60, how about 60?
Okay?
So it says the angle of depression changes from 22 to 46, but if the car's moving towards this point and
All these numbers right there.
22,
It's going in reverse.
is it? That's what's confusing. It's
It's
showing me
probably
22
reverse.
here and 46 here, but getting bigger.
So are you asking about the car problem?
Yes, yeah, the wording is just
The
confusing.
wording's confusing, yeah.
Pictures.
And I think also in that one, the drawing may not be very
The
complete.
It's getting lighter.
But the angle's getting smaller.
Yeah.
So here it is.
No, but it says the car moving toward the building.
So if it's talking about an angle of depression, the degree is up at the top of the building.
Yeah, so let's go look at this one here.
It's just a picture. It's not a picture.
Oops.
It's not the picture, it's the wording of the problem.
It would make sense if it said, like, the car's going in reverse, but.
Yeah, or if it just said the angle of inclination from the car to the top of the building.
Okay. So I heard a lot of good discussion about angle of inclination and angle of depression, all that business. So here you are at the top of the building. And so what I like to do is draw a little horizontal line of sight. So here's a horizontal line of sight. And then what you have is you have an angle of depression, which is 46 degrees here. And then you had a angle of depression originally before the car moved toward the building of 22 degrees.
Yeah, no, that doesn't make sense.
And so your angle of depression changes from 22 to 46 degrees as the car moves closer to the building.
Yeah.
Does that make sense?
Yeah.
Now, I think on your test, I'm going to have a more complete drawing on the actual problem, maybe, or than this.
I'm working on this one, that's what cost.
So,
Did you take this whole thing as 46 or just this?
Because if it changes from 22 when he's looking at the car here, like if it changes from 22 when he's looking at the car here, and it changes to 46 when he's the car on Earth, it's 46, right? Yeah.
What?
Oh, yeah.
Because the whole thing's 46.
Yeah, from here all
Yeah.
the way past.
Yeah.
Okay. Yeah, because it, 45 times 5. I didn't put any. Yeah, I didn't put any.
so you can kind of set it up like this if you want, that this is your 46, this is 46 here. And this is your height. We know that's 100. So this is going to be your opposite. Well, no. That's going to be your adjacent, actually.
Trigonometric function angle is
What?
on number 21, that one. I figured it out already.
These don't have this.
So what you have is, you have this is 100 over here.
I have a lot of that. I would figure it out.
Learn to be 90 degrees.
And so your tangent of 46 degrees is going to be equal to your opposite side over your adjacent. And then for the other one, you have tangent of 22 degrees equals 100 over x plus y so x is equal to 100 over tangent of 46 degrees, and x plus y is equal to 100 over tangent of 22 degrees. And you should get these two numbers and subtract them to get this distance here. Does that make sense? So 100 over tangent, 46 degrees. And then you have 100 over tangent, 22 degrees. So your answer is going to be your difference between these two. So you get this answer here minus 96.57, I'll say. So 150.9 feet about, is that right? Is that what you got for that? And here's the thing about this one here doesn't have a multiple choice option or doesn't have a bubble in way of saying that, doesn't really say to the nearest tenth of a foot or anything. That'll be it. Did you get, anybody else get this answer? You got it, Riley? Gives me some comfort, Riley, knowing Riley got it. Makes me feel more confident that I got it right. I hope, but I got other people checking. I've had a lot of people fact check me in this class. Elizabeth does that, Karina does, Becky does. So you guys are doing a good job fact checking me. That's how you get to be a good pre-calculus class, right? Fact check the teacher, ask the questions.
You can get a video out of this?
There's a video going on right now. Now what happens is usually what I'll do for these, I'll choose between 5th and 6th period. And frankly, if we go over more questions during this period here, this is the one I'm going to do. I think the other day, I showed this one, this class. What happens is, the other class, I show them a lot because sometimes I'll make a mistake during 5th period that I figure out, oh, I corrected my mistake during 6th period.
So basically, these two are, so,
Plus, I spend a lot of time erasing this class too because of getting prepared for next class. Riley, you got your good calculator for this one?
Yes.
Checked out calculator? Good. Speaking of which,
It's kind of a better representation.
get these together here.
So like if you take one of those down, it's what change on these lines and down angles, that one negative and all those so like negative 180 comes over here, positive 180 comes over here, and maybe on this one, it starts with the
Here's the top, on the left, I mean on the right.
yeah, and then these
So,
like
or it's one left and right. You're looking at here.
but one of them
There you see a
yeah, one of them
little
has to be negative.
Now, the other ones are also here. But those two other ones to the side,
No,
I
it's like
split in half and mirrored on
we
it.
got this one,
And then
30, you know, that.
those images go here. Also, they're still in half. Once you go to here, they're not split in half anymore, it's just their bodies and reverse. But here, like internet or something.
Every 21. Did you go with that mirror?
Yeah. I did. It was way more complicated than I had planned. Just simplified. I had a lot of.
Okay, question on these other problems here. Or questions?
I forgot what a reference angle is. These might be teachers the other thing.
Which is a reference angle problem?
It says for an angle measure, or for an angle that measures 5 pi over 3 in standard position, what is the value of this reference angle?
Okay, yeah, that one here, we did that one, that's gonna be 60 degrees.
Look right here.
Keaton or Keelan or 13?
13,
Yeah.
Yeah, I need help with that one.
so here we have angle of depression. Top of the lighthouse, 130 feet above, so this is your 130 feet above water. Okay, lighthouse above water is 6 degrees.
I don't deal with that.
So here we have our buoy right up here, which is a little floating thing out here, the flag on it or something like that. So this thing is out here, the ocean angle depression of 6 degrees. There's your angle of depression. So you're asked for horizontal distance. So your distance so here's your angle, which you can put here 6 degrees. So your tangent of 6 degrees is equal to 130 over your horizontal distance. And so you go ahead, your horizontal distance is going to be equal to 130 over tangent of 6 degrees. So 130 over tangent 6 degrees should be your answer on this one. So 1,239 feet. 1,239 feet. That's the nearest foot. It doesn't say anything about units here.
Question.
Yes.
It says the angle of depression to a buoy buoy in the middle of the bay from the top of the lighthouse. So wouldn't the 6 degrees be?
What do you think that?
Well, here, the thing about it is, if you think about that, your angle of depression won't make sense from the bottom of the lighthouse because you're just going to be looking at horizontally.
Yeah, but what do you put at the top of the lighthouse?
Yeah, from a top of the lighthouse to the buoy.
I don't know how to ask this question without drawing it out.
Okay, that's fine.
So,
Yeah,
like, you have your little boot lighthouse.
Lighthouse, yeah.
And then you have your buoy. Once the angle of depression, where do you put it here if you're looking for this? This is 130 feet
no, because that's not your angle of depression. Angle of depression
from the top.
is always going to be related to your horizontal. So you're going to have So you're gonna be depression because it's gonna be this angle drop here. So here's your 6 degrees here, that's your angle depression because that's
So
almost the
instead
other
of
side.
6,
Now-
this would be
84, yeah. So, but, so you can use that if you want to. And what Elizabeth is doing here, she's saying, well, your angle of depression is 6 degrees, but this angle over here is going to be 84 degrees. And it has to do with cotangent. So what we have is, in this case, the tangent of 84 degrees is going to be equal to your distance, horizontal distance, over 130. And so if you get D equals 130 times tangent 84 degrees, times tangent 84 degrees. So you're going to get the same distance here, right? And this is the definition of cotangent, because what it is, it's the tangent of the complement. Okay? So this cotangent is the tangent of the complement, and the complement is 84. And so that's how we get the relationship between tangent and cotangent. Okay? Okay, we have a few minutes of class time left. So you have questions on some of these later ones here? The reference angle here. This is quadrant 3, so you subtract from 180 will be your answer for that one.
So can you show us how to make a reference angle again? Because I can't remember how.
Yeah, so your reference angle, you take a standard position angle, which in this case is 250 degrees. So here's your 250 degree angle. Comes all the way around here. And I know it comes right here because that's 270. That's 270 here. So here's 250. And what you want to have is you want to have the angle that goes right to the x-axis. So the reference angle is this thing right here, which is going to be 250 minus 180, which is going to be equal to, that 70 degrees? 70 degrees. So your reference angle here, that is 70 degrees. And you go by going straight up or down to the x-axis. So here's your 70 degrees right here. So that's it. The key thing here, if you're in quadrants 2 or 3, it's going to be relative to 180. So in quadrant 2, it'll be 180 minus whatever angle it is here. In quadrant 3, it's going to be that angle minus 180. In quadrant 4, it's going to be 360 minus our reference, minus that angle, and you get a reference angle. In quadrant 1, the reference angle is itself. Here's 18 is a little bit tricky because you're given an arc length problem, but you're given a diameter and not a radius. So you got to watch out for that.
Oh, look at it, yeah. I fell for that.
Yeah, just kind of read through and be careful about it. Just kind of think. Good.
Is it 360 minus whatever it is for the arc angle?
On 18,
Yeah.
well, on 18, what you have is S equals R theta,
Yeah.
and you want to find that arc. What is the length of the arc? Forgot the question mark here. But the length of the arc is going to be your radius, which is 8
Times 70.
times 70 degrees, but it has to be in radians. So 70 degrees times
180.
pi
Oh,
180. So 8 times 70 times pi divided by 180 is going to be your arc length. That's going to be 570. No, 8 times 70 times pi divided by 180. 8 times 70 times pi. And we divide that by 180. So arc length will be 9.77. 9.77, which is going to be equal to 9.8 according to the 10th.
yeah.
So 9.8. 9.8. So that's that. We finds are about out of class time.